Good day, class. Today we are going to be discussing about measurements in physics. This is a very important area that you need to know when we talk about measurement in physics. Now, to study and establish the link between matter and energy, of course, we have defined physics as a branch of science that studies matter and its motion, right? Yes. Then, with as well as its interaction between force and energy. Now, for us to establish the relationship that exists between matter and energy, we need to measure physical quantities. Now, in the physical quantity, it has two parts. When we talk about physical quantities, we have two parts. The first part is a number, and the other part is the unit. The number states the size of the quantity measured. I want to measure the length of this board. After measuring this length, let's say this is 8 feet. The measurement of this board is 8 feet. The length of the board is 8 feet by 4 feet. I have measured the 8 feet that I just said. Okay, the 8 feet is that 8 there is the number that we are talking about, and that number tells us that what? That's the quantity, the size of the quantity. What quantity we are talking about? Length, right? Are we following? Yes. You can respond. The quantity we are talking about here is what? The length. I can tell a student to, okay, we want to measure the mass or the weight of the student, and the student climbs on a weighing machine, and the meter reads 60 kg. That 60 is the number, and that number tells us how big, the size of the quantity we are measuring. Are you following?
Yes, sir.
So that's the size, which is the number. Then the other part, which is very important also, is the unit. The unit identifies the quantity being measured. Even if I don't tell you that I am measuring the mass of the person, but I told you this mass, the student weighs 60 kg. That kg tells me about what I am measuring. Are we together? It tells me about what? What is being measured. If I tell you 60 centimeter, what will you think about? Length, right? If I tell you 60 liters, what will come to your mind? What quantity am I measuring? Volume. So it is very important for you to know this unit, and that's what we are talking about now. So we have some units, we call them fundamental quantities and their units, and we also have those that we call derived quantities and units. Okay, so let's do right. So types of quantities. So under types of quantities, we have one fundamental. Okay, I think I can. There are two types. There are two types of quantities: fundamental and derived. Fundamental and derived quantities. What if you are asked to state what is a fundamental quantity? Is a quantity that on which other quantities depend. That means is a basic quantity where other quantities are gotten from. So we have 7 of them. Okay, I think let me write about that. So, one, fundamental quantities. Fundamental quantities. these are basic quantities upon which other quantities depend. Other quantities depend. Now we have a table that shows the quantities, the fundamental quantities. We have 7 of them, 7 fundamental quantities. These are the quantities. So we rule a table. This is the units. Let me give you enough space for it. Unit and the symbol. The first one we're going to talk about is the length. Everybody say length. Length. What will be the unit of length? The standard unit of length is what? Meter. Meter. The symbol for meter is M. For mass, the unit is kilogram. The symbol is kg. For time, I think everybody should know that. Seconds. The unit is S. For temperature, we use Kelvin, and that's K. We also have electric current. Electric current, and that's ampere. A. 6. We have amount of substance. Amount of substance. Who can guess this? Mole. And you have MOL dots. Then the last one is luminous intensity. And this is measured in candela, CG. These are all these that I've mentioned and written on the board. We call them the fundamental quantities and their respective units. Can we go by it again? Please, let's start from 1. Length, what's the unit? Meter. Everybody should talk. Stop writing. What's the mass? Mass, number 2 is what? Mass. What's the unit? Kilogram. The third one? Time. The unit is what? Seconds. 4. Temperature. Kelvin. Electric current. Ampere. Amount of substance. Mole. Luminous intensity. Candela. So these are the fundamental quantities and their respective units. So I will expect every one of you to make sure you learn this by heart, because you may be asked in exam situation. You may not even be asked this way. You may be asked to use. You will be using these quantities and units from time to time. So you have no choice than to learn it. So let's quickly. Now these basic units are stated in the internationally accepted units. So there's something we call, these units above are stated in the internationally accepted units. That is System International units. And that is what we call SI units. Somebody say that again? SI units. Of course you know that length we can measure small length in what? centimeters, millimeter. Yes or no?
Yes.
But that is not the standard, the system international unit, the SI unit. So if you are asked to record anything in physics, we make use of the standard unit, which we call the what? SI unit. You may measure a particular, listen very well and listen carefully. This meter rule is 0 to 100. We call it a meter rule because it's having what? 100 what? Divisions in centimeters. And you know, 100 centimeters make what?
1 meter.
1 meter. So if I'm going to record this, let's get the fact that it is 100 centimeters. If I'm going to record it in physics, I'm going to write what? 1 meter, because that's the SI unit. Because most of the other units are in meters and they have units in meters, like Newton meter and the rest. So you cannot write Newton meter and record your length in centimeters. So that's what we call, when you are solving in physics, all your units must be, they must be in what? In their conventional units. That means they must be in the SI unit. So if I see mass, I'm not supposed to write mass in gram, except if otherwise stated that find the answer in grams. Are you following me? Time, you may see time in hours. You have to convert to what? Seconds. Are we getting it?
Yeah.
Temperature, you may see it in Celsius. You have to convert to what? Kelvin. These are the standard units, and we call them what? What do you call them? System International Unit. That means it is the unit that it is generally accepted anywhere in the world for solving. Do you understand that?
Yes.
The next type of unit or quantity is what we call what? The derived quantities. So we know that the fundamental quantities are independent of other quantities. Do we agree?
Yes.
They are independent of other quantities. That means they do not depend on other quantities. They stand on their own. But when we talk about the derived quantities and units, 2, derived quantities these are quantities that depend on the fundamental quantities. They are derived from two or more fundamental quantities. Now we're going to start with this. Let's have the quantities here in the table. Quantity. We have the table here that also shows the derivation. And you also have the units here. The unit. Okay. Let's start with 1. Everybody, area. Stop writing. What is the formula for area of a rectangle? Length times what? Breadth. The length times the what? The breadth. So we can write this as what? A equals to what? L times breadth, right?
Yeah.
What is, you know, length? Look at this, everybody. This table here has this is length, right? And this the breadth of the table. Both of them are length, right? They are distances of one point to the other. But this is shorter length. That's why it's called width or breadth. Are we together? So, what am I going to use to measure this? Is in what? Meters. This is also in meters. So, what I do here is length is in meters, breadth is also in meters. Meters times meters, apart from your indices, you have what? Meters squared. This is the unit for area. This SI for area. Volume V. Volume is length times breadth times height. That's what? Can you tell me, everybody? Meter times meter times meter. What will that give us? Meter cube. The next thing is density. Density. Look at how the unit, the symbol for density is. This is what we call rho. Somebody say rho. It's a Greek letter, R-H-O. So it looks like an elongated E or a cursive P. So you don't write it like P, you don't write it like E. So it's in between. So you draw it this way. Do you understand? That symbol is rho, density. Density, rho is mass over volume. Are we together? Yes. What is mass? Kilogram, right? Yes. We write kilogram over what? What's the volume? Meter cube. When meter cube, according to your indices, this meter cube, when it comes up, it becomes what? Kilogram per meter cube. You can write like this or kilogram per meter cube. Are you following? You get that? The next one, let's write speed. Speed equals to what? Distance over time. What is the distance measured? Is measured in what? In length. So we write, what we write? Meters. And what is time measured in? Seconds. When this seconds comes up, it becomes what?
Raised to power
Meter raised to power minus 1. So we call this, right? Meter per second. Everybody say that. Meters per second. Then we have another one, we call it velocity. Small v. It's quite different from volume. Velocity, small v is what? Displacement over time. Displacement is a distance covered in a specific direction. So it's also a distance. So we are going to write meters right here over what? Seconds. What are we going to write here? ms raised to power minus 1. That's meter per second. The next one we can guess acceleration. Acceleration A. A equals to what? Velocity over time. That's it. Acceleration is defined as the time rate of velocity or change in velocity with time. Now, what is velocity? We bring this, right? Meter per seconds, right? Over what? What's time? Seconds. When this seconds comes up, do you know it becomes ms raised minus 1 times s raised minus 1. According to indices, when you have two of these and they have been multiplied, you add up the what? The indices, right? So this will become what? ms raised to minus 1 plus minus 1, right?
Yes.
So what will be the unit of acceleration? Meter. So you say this ms raised to minus 2. And that's what we call it meters per second square. You should stop writing and listen. This is very important. If you don't get it now, it will become a problem for you. this meters per second squared. Everybody say meters per second squared.
Meters per second.
What is the unit of velocity? Meters per second. What is the unit of acceleration?
Meters per second squared.
What is the unit of speed?
Meters per second.
What is the unit of density?
Kilogram per meter
Kilogram per meter
cube.
cube. Again? Kilogram per meter cube. The next one we talk about is work. No, let's go to force. We need force first. Force F is given as what? Mass times acceleration. Now, what is mass? Kilogram, right?
Yes.
What's our acceleration? If you see dots,
Meters
it means times, right? Meter per second squared. This whole thing is what we call Newton. So we just write Newton. So this is Newton. We N, right?
That is the unit.
When we play that unit, N. Then the next one is work. Work or energy, they are the same. So let's say work. Work equals what? Force times distance. You should know this. Force times distance, right? What is force? Yeah. Newton. What is seconds? What is what? Distance. Let me write it well for you. Force times distance. What is force? Newton. Times what? What is distance? Meters. Distance is measured in what? Meters. So we are going to write Newton meter. So this Newton meter is what we call joules. J. Are you following?
Yeah.
The next one is after what? Power. Power P is equals to power equals to what? Work done over time or energy over time. What is work done? From here? Joules, right? What is time? Second. So this is what? Joule per second. This joule per second is what we call the watt. Watt. W. Are you following? Are you following? Now, we also have other ones like momentum. Momentum P. Momentum P is P equals to mass times velocity. Who can tell me what I'm going to write here? What is mass? What will I write? Kilogram times meter per second. This, when we get to year 11, you will see the units. You will understand this. Now, kilogram meter per second is the same thing as Newton seconds. I don't want to prove that now. When we get to class, so Newton seconds. So you can write this here. Newton seconds. Let's take the last one, and that is pressure. You should know the formula for pressure. Pressure is yes. Pressure is what? Force over area. Somebody say force over area. What is our force? Newton. What is area? Meter squared. This will become what? Newton per meter squared. This Newton per meter squared, we can also call it Pascal. Somebody say Pascal. So on this note, if you understand this is the beginning. So you know how to derive it. Even if you forget, you should be able to what? Please, when you get home, make sure you try this from the beginning again. Look at it one after the other and check if you can use this to derive your other derived quantities. Okay, you can write. Okay, so we have what? The multiples and submultiples of prefixes. You know, in English language, you know what prefixes are?
Yes.
What are prefixes?
They are words that are added to the
They
beginning.
are words that are added to the beginning of a main word, right? So we also have that in physics. So we have what we call the multiple prefixes. These are used to express higher units. That's what we call multiples. Then we also have the submultiples. Also, those are used in they are used to represent lower units. Now let's look at hexa. Hexa is abbreviated as E, capital letter E, and that stands for 10 raised to power 18. So when you hear the word hexa, it means 10 raised to power 18. We also have peta, peta P, that's 10 raised to power 15. Tetra is T. You have heard of terabytes. Before everybody uses gigabyte, megabyte, there was a time our smartphones were just using kilobytes, megabytes. Then we upgraded to what? Gigabytes. Then now we are having what? Terabytes. Most of your storages your storage devices are now in terabytes. Some of your laptops have hard drive of space 1 terabyte. That means terabytes. So what's the meaning of terabyte? That means 10 raised to power 12. Then we have the next one, gigabytes. Giga, not gigabyte. Giga is the prefix. Are you getting it? I can say gigagram. Are you getting it? That means that the gram is 10 raised to power 9. Are you following? So we have mega M, that's 10 raised to power 6. Mega from the word million. So megawatt means million watts. That means 10 raised to power 6 watts. So all these words can be used with any of these quantities that we have mentioned. Are you following? We have kilo. You all know kilo, right? Kilo K, that's what 10 raised to power 3. We have hecto. Hecto is H. That's 10 raised to power 2. Then we have deca. Deca, D, 10 raised to power 1. Are we together? These are the multiple prefixes. Then when we go to the submultiple prefixes, we'll start with deci. Deci, small d, 10 raised to power minus 1. We have centi. You know that? Centi, 10 raised to power minus 2. We have the next one with what? Milli. You have heard of milli before. Millimeter, milligram. All these things are just prefixes. So milli, 10 raised to power minus 3. The next one is micro. Micro. The unit is, you write a U, that's this, that's micro. Mu is the Greek letter, which stands for 10 raised to power minus 6. Are you following? The next one after micro is nano. Nano is small m, 10 raised to power minus 9. We have pico, which is small p, 10 raised to power minus 12. We have femto, which is F, 10 raised to power minus 15. And we have atto. Ten raised to power minus 18. So our scope will not cover more than these ones that have been stated above. Even majorly, you won't even get to this point better in your calculation. So most times we are always between this and this,
And every other thing here, 10.
12. Because when you get to year 12, you'll be, when you talk about capacitors, capacitors are measured in picofarad, microfarad, nanofarads. So you have to know all these things. This, some senior students always have problem with this. When they get to that stage and they don't know the unit of these things, when they see it in questions and they become confused because they don't know what each of these things, some of them don't know what these things stand for. So you have to learn it by heart. Thank you for watching.